Hi, I'm Jim Green, Director of Planetary Science at NASA. Planet X is out there, we'll find it together. NASA has just unveiled evidence of Planet X hiding behind the Sun. This revelation, featured on the Joe Rogan Experience, has reignited the age-old debate about hidden celestial bodies in our solar system. After years of speculation and scientific inquiry, the confirmation of Planet X could reshape our understanding of the world. But how did NASA uncover this elusive planet, and what implications does it hold for future space exploration? Join us as we dig into this groundbreaking discovery and explore the mysteries of Planet X. NASA has just made a significant discovery. There is strong evidence that Planet X exists. This finding was the consequence of careful observations and sophisticated data analysis, and it did not occur by accident. It all began with unusual gravitational anomalies observed in the outer regions of our solar system. These anomalies couldn't be explained by the known planets alone. Astronomers noticed that certain objects in the Kuiper Belt, a region beyond Neptune filled with icy bodies and dwarf planets, were behaving strangely. Their orbits were being influenced by an unseen force, suggesting the presence of a massive, yet undiscovered, planet. To investigate further, NASA deployed some of its most sophisticated technology. The WISE Wide Field Infrared Survey Explorer telescope, which scans the sky in infrared, played a crucial role. Infrared technology is particularly effective for detecting objects that are otherwise hidden in the vast expanse of space. Alongside WISE, data from the Hubble Space Telescope and ground-based observatories were also crucial in gathering comprehensive information about this mysterious object. With preliminary data in hand, the next challenge was to confirm the existence of Planet X. This was no easy task. The planet, situated far beyond Neptune and hidden behind the Sun from our vantage point, required precise and persistent observation. The confirmation process began with rigorous analysis of the gathered data. Scientists used complex algorithms to model the gravitational effects that Planet X would have on nearby celestial bodies. This involved running numerous simulations to match the observed anomalies with the predicted influence of a hypothetical planet. One significant challenge was the sheer distance and faintness of Planet X. Unlike the inner planets that reflect sunlight brightly, Planet X's distance from the Sun makes it incredibly dim and hard to detect with visible light telescopes. The team had to rely heavily on infrared observations, which can pick up the faint heat signatures emitted by distant objects. Further complicating the process were the limitations of current technology. Detecting such a distant object requires incredibly sensitive instruments and clear, unobstructed views of the sky. Weather conditions, atmospheric disturbances, and even the alignment of the Earth and Sun all played roles in affecting the quality of observations. Despite these hurdles, the persistent efforts paid off. Over months of continuous observation and analysis, a consistent signal emerged, pointing to the existence of a large planetary body. This signal matched the predicted location and characteristics of Planet X, giving scientists the evidence they needed to announce its discovery. But the journey doesn't end here. What more can we learn about this elusive planet? How does its existence reshape our understanding of the solar system? Planet X is estimated to be a colossal entity, significantly larger than Earth. Preliminary data suggests it could be approximately 10 times the mass of our planet, classifying it as a super-Earth or a mini-Neptune. Its sheer size explains its powerful gravitational influence, which affects the orbits of objects in the distant Kuiper Belt, leading to the initial suspicions of its existence. The orbit of Planet X is another fascinating aspect. Unlike the nearly circular orbits of Earth and most other planets in our solar system, Planet X follows a highly elliptical path. This means that it swings in closer to the Sun at one end of its orbit and then travels far out into the outer reaches of the solar system at the other. This elongated orbit is estimated to take anywhere from 10,000 to 20,000 years to complete one full revolution around the Sun. When it comes to its composition, scientists believe that Planet X shares similarities with Uranus and Neptune. It likely has a solid core made up of rock and metal, enveloped by layers of ice and a thick gaseous atmosphere. In addition to explaining its enormous size, this composition also suggests possible origins and surface conditions. Comparatively, Planet X stands out among the known planets in our solar system. While it is smaller than the gas giants Jupiter and Saturn, it surpasses Earth in mass and size. This places Planet X in a unique category, bridging the characteristics of terrestrial planets like Earth and the ice giants like Neptune. The main explanation for why Planet X has remained elusive is because of its position in relation to the Sun. Often, from Earth, Planet X is positioned so that it is obscured by the Sun and cannot be seen. The planet is practically impossible to identify with ordinary telescopes due to the Sun's tremendous brightness and glare, which makes its alignment a considerable observational challenge. Additionally, the unique orbital path of Planet X adds to the difficulty. Its highly elliptical orbit means that it spends much of its time in the distant outer regions of the solar system, far beyond the reach of most observational instruments. Only during specific points in its long orbit does it come closer to the Sun and potentially into a position where it might be observable from Earth. Another complicating factor is the inclination of Planet X's orbit. Unlike the relatively flat orbital plane that most planets follow, Planet X's orbit is tilted at a significant angle. This tilt means that it often travels well above or below the plane of the solar system, further reducing the chances of it being spotted during routine sky surveys. One of the earliest references to a mysterious planet comes from ancient Sumerian texts. The Sumerians spoke of a celestial body called Nibiru, which some modern theorists believe could be Planet X. According to these ancient records, Nibiru had a long elliptical orbit and was associated with cataclysmic events on Earth. While these stories are shrouded in myth, they have captivated imaginations and fueled ongoing speculation. In the 19th century, astronomers like Percival Lowell dedicated their careers to the search for a hidden planet. Lowell was convinced that irregularities in the orbits of Uranus and Neptune were caused by a distant, unseen planet. His relentless pursuit led to the hypothesis of Planet X, a term he coined. Although Lowell never found Planet X, his work laid the groundwork for future discoveries, including the eventual identification of Pluto, which for a time was thought to be the mysterious planet he sought. The models of planetary formation are one area of notable influence. By casting doubt on accepted wisdom, Planet X raises the possibility that there are more big objects in the outer solar system than previously believed. Its existence suggests that the early solar system was a considerably more active and chaotic environment, possibly resulting in the ejection of massive planets into far-off orbits. Additionally, the gravitational influence of Planet X can help explain the peculiar orbits of certain trans-Neptunian objects, TNOs. These TNOs exhibit unusual clustering and orbital patterns that cannot be accounted for by the known planets alone. Planet X's gravity offers a plausible explanation for these anomalies, providing a more complete picture of the gravitational landscape of our solar system. The discovery of Planet X also opens new frontiers for future space missions. Missions to study this distant planet could provide invaluable data about its composition, atmosphere, and potential moons. Such expeditions would offer insights into the circumstances of the outer solar system, in addition to expanding our knowledge of Planet X itself. How will NASA and other space agencies adapt their exploration strategies in light of this discovery? What new technologies will be developed to probe the mysteries of Planet X? As we ponder these questions, it becomes clear that the discovery of Planet X is not just a milestone in astronomy but a doorway to countless new explorations and understandings. The Joe Rogan Experience, JRE, a podcast, has a knack for bringing complex topics into the mainstream, and the episode on NASA's discovery of Planet X was no exception. In this riveting discussion, Rogan sat down with renowned astrophysicist Dr. James Winters to explore the details of this groundbreaking revelation. Rogan and Winters discussed how ancient civilizations like the Mayans might have known about this mysterious planet, referencing the mythical Nibiru. It's fascinating to think that ancient texts might have been hinting at a reality we're only just now beginning to confirm, Winters remarked. The conversation also ventured into speculative territory, considering the potential for undiscovered moons around Planet X and what this could mean for future missions. Rogan, ever the inquisitive host, asked, could there be life on any of these moons? What kind of missions would we need to find out? The revelations from the JRE podcast set off a wave of reactions across both the public and scientific communities. On social media, the topic trended for days, with hashtags like #PlanetX and #JRE sparking widespread discussion. Many listeners expressed awe and excitement about the discovery, while others were skeptical, demanding more concrete evidence. The scientific community was abuzz with debates and discussions. Some scientists hailed the discovery as a monumental leap in our understanding of the solar system. Dr. Elena Sanchez, a planetary scientist, tweeted, "The confirmation of Planet X is a game-changer. It forces us to rethink the dynamics of our solar system and the formation of planetary bodies." However, not everyone was convinced. Critics pointed out that more data is needed to fully understand Planet X and its characteristics. Dr. Harold Jenkins, an astronomer, commented, "While the evidence for Planet X is compelling, we must be cautious. Extraordinary claims require extraordinary evidence. We need more observations and peer-reviewed studies. The sensitivity and resolution of current technology are likewise limited. It is difficult to obtain extremely high-resolution imaging with current instruments, which is necessary for the detection of such a distant object. To take sharper and more comprehensive pictures of Planet X, more sophisticated telescopes with increased sensitivity and resolution are required. Future advancements are essential to overcome these limitations. More sensitive detectors and improved resolution capabilities in upcoming space-based observatories, like the James Webb Space Telescope, will significantly enhance our ability to observe distant objects. These innovations promise to provide unprecedented detail and clarity, paving the way for more definitive observations of Planet X. With the confirmation of Planet X's existence, potential safety concerns arise regarding its impact on Earth and the solar system. Could this massive planet pose any risks? Planet X's gravitational pull is one of the main worries. Its size implies that it may have an impact on the orbits of other celestial bodies. Comets and asteroids may be diverted from their intended course and sent into the inner solar system by its gravitational attraction. However, the short-term risk would be diminished because these consequences would take a long time to manifest. An alternative hypothesis posits that our solar system may have been historically impacted by Planet X. According to some scientists, comet showers from the far-off Oort cloud may have been caused in the past by Planet X's gravitational pull, which could have resulted in massive extinctions on Earth. Even while this is only conjecture, it emphasizes how crucial it is to keep an eye on Planet X's path and impact. Expert opinions underscore the need for international collaboration in monitoring Planet X. Dr. Laura Simpson, a planetary scientist, notes, international cooperation is crucial for observing and studying Planet X. Sharing data and resources globally enhances our ability to respond to potential threats. As we continue to explore the mysteries of Planet X, what other challenges and discoveries lie ahead? How will new technologies shape our understanding and ensure the safety of our solar system? The planned Planet X probe, a spacecraft intended to visit the outer solar system and collect up-close data, is one of the most eagerly awaited missions. Modern instruments on this mission will be used to examine the planet's atmosphere, surface characteristics, and possible moons. The mission's goal is to provide important information regarding the composition of the planet and the properties of its orbit. Furthermore, NASA plans to use the spacecraft New Horizons, which has already produced groundbreaking data on Pluto and the Kuiper Belt, in conjunction with other ongoing missions to acquire some first information about Planet X. As it travels through the outer solar system, New Horizons may be diverted to study Planet X. This strategy eliminates the urgent requirement for brand new initiatives by enabling NASA to make use of existing technology and missions to develop a more thorough understanding of Planet X. But what specific insights are scientists hoping to gain from these missions, and how will this information enhance our understanding of the solar system? As we prepare for these exploratory endeavors, the anticipation is palpable. The European Space Agency, ESA, has expressed keen interest in collaborating on missions to study Planet X's upcoming missions, such as the Euclid telescope designed to study dark energy and dark matter, can also be instrumental in observing distant celestial bodies like Planet X. By pooling resources and expertise, NASA and ESA aim to enhance the effectiveness and scope of their research. Russia's Roscosmos and China's CNSA are also key players in this global endeavor. Both agencies have advanced space programs and have shown interest in space exploration. Collaborative missions with Roscosmos and CNSA could involve sharing data, joint research initiatives, and potentially co-developing new spacecraft to reach and study Planet X. Collaboration between nations goes beyond simple resource and technology sharing. It also calls for teamwork in the interpretation and analysis of data. Space authorities may ensure that the results from Planet X are thoroughly examined and comprehended by assembling the world's best minds. This cooperative method guarantees a wide range of viewpoints and experience while also expediting the research process. The importance of global cooperation in space exploration cannot be overstated. As Dr. Emily Jong, an astrophysicist at the European Space Agency, notes, the discovery and study of Planet X represent a significant leap in our understanding of the solar system. By working together, we can achieve much more than any single agency could on its own. Percival Lowell was among the first most important people to contribute to this endeavor. Lowell postulated the existence of a ninth planet, which he named Planet X, in the early 1900s based on peculiarities in Neptune's and Uranus's orbits. He believed that these planets were being pulled in a gravitational direction by a far-off large object. Lowell dedicated years of his life to this search, building the Lowell Observatory in Flagstaff, Arizona, specifically to find Planet X. Despite his rigorous efforts and advanced equipment for the time, Lowell never succeeded in locating the elusive planet. However, his work inspired future astronomers and set the stage for subsequent discoveries. Astronomer Clyde Tombaugh of Lowell Observatory made a significant discovery in 1930 that at first appeared to support Lowell's views. It was believed that Pluto, which Tombaugh found, was Planet X through a process called blink comparison. This process involves comparing two images of the night sky to identify movement. Tombaugh painstakingly searched the skies until he located the little far-off object. Although Pluto was regarded as the ninth planet, it quickly became clear that its modest size could not explain the gravitational forces that Lowell had noticed. The hunt for Planet X went on, but it soon became apparent that finding it would be far more difficult than first thought. An important lesson learned was the value of accurate and ongoing observation. The sensitivity and resolution of photographic plates, widely used by early astronomers, were constrained. These restrictions frequently resulted in missed or false positive detections. Technological advancements, like digital imagery and powerful satellite telescopes that provide more resolution and greater sensitivity, have greatly assisted modern searchers. Another significant advance was the realization that the solar system is significantly more dynamic and inhabited with a variety of tiny objects than previously believed. The field of planetary astronomy underwent a paradigm shift with the discovery of the Kuiper Belt, an area of frozen bodies and dwarf planets located beyond Neptune. With this knowledge, astronomers could see that any possible Planet X would probably be far farther away and harder to find than first thought. These early searches' historical background has a direct bearing on current initiatives. Today's astronomers forecast potential planet placements by utilizing complex mathematical models and computer simulations like Lowell's original theory, but with far more accuracy. These models are based on the gravitational effect seen in the outer solar system. Furthermore, a more methodical and cooperative approach has resulted from the lessons learned from previous mistakes. Astronomers from different countries increasingly collaborate and share resources and data to improve the odds of success. It was thanks to this attitude of cooperation and state-of-the-art equipment that NASA was able to confirm Planet X recently. How have these historical efforts shaped our current understanding and methods? What can we expect from future searches based on the lessons of the past? The enigma of Planet X has long captivated the public imagination, finding its way into various facets of popular culture. This mysterious planet has been a staple in movies, books, and TV shows, often blending scientific theories with imaginative storytelling. In cinema, Planet X has been a popular theme in science fiction films such as *The Man from Planet X*, 1951, and *The Day the Sky Exploded*, 1958, which delve into the idea of an undiscovered planet having dramatic effects on Earth. More recent movies like *Melancholia*, 2011, explore the psychological and existential implications of a rogue planet on a collision course with Earth. Literature has also played a significant role in popularizing the concept of Planet X, works like Zechariah Sitchin's The 12th Planet have intertwined ancient astronaut theories with modern science fiction, suggesting that ancient texts hint at the existence of a hidden planet. Such narratives blend history, mythology, and science, engaging readers with the tantalizing possibility of undiscovered worlds. Television has similarly embraced the mystery of Planet X. Series such as The X-Files and Doctor Who have featured episodes that speculate on hidden planets and their potential impact on humanity. These episodes often pinpoint the thrill of discovery and the unknown, resonating with viewers and sparking curiosity about real-world astronomical research. These depictions in popular culture have significantly influenced public interest in astronomy. By dramatizing the search for Planet X, movies, books, and TV shows have introduced complex astronomical concepts to a broader audience. This widespread fascination encourages a greater appreciation for space exploration and the scientific pursuit of knowledge. The discovery of Planet X has become a major public story, thanks in large part to the efforts of mainstream media. The latest discoveries from NASA have been widely reported by media outlets, with an emphasis on the advances in science as well as the wider ramifications for our comprehension of the solar system. Leading publications like The New York Times BBC and National Geographic have provided in-depth coverage of the discovery process, the data supporting Planet X's existence, and the potential for future exploration. These articles aim to demystify the science behind the discovery, making it accessible to a wide audience and pinpointing its significance. However, there are difficulties with media coverage. Sensationalism can result from Planet X's appeal, as some media sources prefer dramatic headlines to objective reporting. As a result, false information or overstated statements may proliferate and obscure the real scientific conversation. Social media has further amplified the discussion around Planet X. Platforms like Twitter, Facebook, and YouTube have seen a surge of posts and videos ranging from credible scientific analyses to speculative theories. This rapid dissemination of information has a dual effect: it democratizes access to knowledge but also facilitates the spread of misinformation. How will the portrayal of Planet X in media and popular culture evolve as we learn more about this mysterious planet? What impact will this have on public interest in space exploration? The Kuiper Belt, a region beyond Neptune filled with icy bodies and dwarf planets, also shows unexpected orbital characteristics. Some of these objects have highly elliptical orbits and are tilted relative to the plane of the solar system. Scientists believe that the gravitational influence of a massive, distant planet like Planet X could be responsible for these unusual orbital traits. By perturbing the orbits of Kuiper Belt objects, Planet X's gravity might be the force driving these anomalies. Our understanding of planetary dynamics as a whole depends on our ability to comprehend these gravitational anomalies. It puts current models to the test and compels scientists to incorporate fresh variables into their computations. Astronomers now need to update their models to take Planet X's influence into account after its confirmation. This change may improve our ability to forecast how things will behave in the outer solar system and give us a better understanding of the dynamics at work in this far-off area. The idea of planetary migration is one area of significant influence. Current models suggest that the giant planets in our solar system, like Jupiter and Saturn, move to their present orbits from their original places. The finding of Planet X raises the possibility that this migration was far more intricate than previously believed. Gravitational forces with other massive planets may have forced Planet X into its far orbit. According to this theory, the final configuration of the planets was mostly shaped by gravitational forces in a more chaotic early solar system. The discovery of Planet X also prompts potential revisions to existing models of planet formation. For instance, it might indicate that planet formation processes can produce a wider variety of planetary types and orbits than previously considered. This broader understanding could lead to new classifications of planets and a more nuanced view of how planetary systems evolve over time. What does this mean for future research in planetary science? How will these new insights reshape our search for exoplanets and our understanding of the universe? One such person is the American astronomer Percival Lowell, whose curiosity with the unknown had an enormous impact on him because of his upbringing and personal convictions. Percival Lowell postulated the presence of a ninth planet, which he called Planet X, beyond Neptune. He was so devoted to this mission that he founded the Lowell Observatory in Flagstaff, Arizona. Even though Lowell was unable to locate Planet X, his thoughts and observations served as a basis for later discoveries. Another important scientist who approached the search methodically and determinedly was Clyde Tombaugh. Originally from Kansas, Tombaugh had a background in farming. In 1930, while employed at Lowell Observatory, his love of astronomy led him to make the discovery of Pluto. Even if it was subsequently reclassified, this finding was nonetheless a huge accomplishment and increased interest in the hunt for far-off celestial bodies. In recent years, Dr. Michael Brown of Caltech has become a prominent figure in the search for distant planets. Brown's discovery of several large objects in the Kuiper Belt, such as Eris, challenged existing definitions of what constitutes a planet. His work, driven by relentless curiosity and a desire to push the boundaries of our knowledge, has reignited interest in Planet X. Brown's contributions have provided new methodologies and insights, advancing the field of planetary science. The public's long-standing obsession with Planet X is entwined with contemporary science fiction and cultural mythologies. There has been a great deal of attention and conjecture due to the attraction of a secret planet. Nonetheless, a good dose of skepticism frequently counterbalances this interest, which is essential for maintaining scientific integrity. This cultural fascination has tangible impacts on scientific research and funding. Public interest can drive support for astronomical projects, influencing funding decisions and prioritizing research areas. For instance, the excitement generated by NASA's recent announcements about Planet X has helped garner attention and resources for further exploration. However, the public's interest is also tempered by skepticism. The scientific community is continually scrutinized with demands for rigorous evidence and peer-reviewed validation. This skepticism ensures that discoveries are thoroughly vetted before being accepted. The debate surrounding the reclassification of Pluto and the confirmation of Planet X highlight the importance of maintaining scientific rigor amidst public enthusiasm. Two factors influence how the public views scientific pursuits. Increased money and support can result from fascination, but skepticism makes sure that claims are examined closely. Science cannot progress without this interaction, which spurs both creativity and responsibility.